I'm an academic foundation doctor up in Edinburgh, and part of that role gives me a clinical research fellowship at the university, and I'm also a research assistant in London at Great Ormond Street. And sort of where the journey all began was when I joined the Star Surge Research Collaborative Steering Committee. I've only just become a doctor over the past sort of 3-4 months, but prior to that, I was a medical student. And the idea behind the group is that we are a set of students who are running collaborative research. So I must admit, my talk's not quite as technical as there's the last one, but more just sort of give some insight into how we use R in collaborative research and healthcare research overall. So just a bit about collaborative research, just because I appreciate we've got a wide range of individuals in the room. My experience with using R is sort of touched upon throughout, what we currently use R for and where we can possibly further utilize R within collaborative research. So collaborative research is defined as the act of working with another person or group of people to create or produce something. And essentially within healthcare, the way that works is that we end up creating a central steering committee, and then we run whether it's regional, national or international studies. So sort of a traditional research model is that you might have lots of single centre audits or hospitals that will run the studies on their own, and you might get 20 patients or so in each centre, but they're all ran as independent units. And the downside to this is you end up with 15 studies that are completed, but they've not communicated with one another, and you're at risk of having different findings between them all, not because of an actual true difference, but just because of geographical location, different demographics. So we end up utilising the collaborative model, which then sort of you group all of those together in centralised data collection, which then produces one multi-centre audit or study, which strengthens the entire process. So that's ended up what we've ended up doing. So what we do is we sort of have to structure the teams that will have the steering committee, which is then where I'm part of large groups, and we design the protocols, overall running of the project. Step down, you've got hospital leads or regional leads. They'll look after the individual centres, and they would effectively have been probably the person that was running the study if it was single centre. And then we have other individuals who collect all our data for us, so that we can then sort of perform the analyses later down the line. One of the things that we do as part of the collaborative model is that we publish under what's known as collaborative or corporate authorship. So if you ever sort of found the research paper, it would just be one name. On this one, it's COVID Surge. And it's only then when you go into the finer details that you'll get the list of everyone that was involved. And the idea behind that is that the attention's more on the results and what we've actually done, and less about who's got their name first underneath the paper, which then sort of keeps people's focus on the important task at hand. So multi-centre with larger samples is a huge benefit. We get higher generalizability of findings, and perhaps less relevant for yourselves in the audience, but it does allow students and less experienced individuals to get involved, because we can sort of tailor their involvement to what's being done. We'll then carry out some of the more complex elements. Can be difficult because the more collaboration you have, generally the larger the number of people involved, and it then becomes difficult to coordinate that. You have to have a well-structured and thought-out protocol. Research protocols are essentially like an ultra-detailed instruction manual on absolutely everything that's being done, or very similar to like a standing operating procedure in other industries. And it does often require some financial or institutional backing. I've been very fortunate over the time to have sort of things like the university support and offer sort of data storage and management. So sort of current use of R and that we use, my first experience, as I said earlier, was within the Star Surge Steering Committee. and I also did a research master's, and I used it throughout then. So I spent about a year working in R. I sort of moved from what were relatively simple analyses into more complex ones. There was a little dip into some machine learning, some loops of code, and I now write pretty much majority of the papers I'm involved in R Markdown with a combination of inline code to pull the stats out and integrated plots, just so you then end up knitting the whole document, and at the end you've got your final finished product that contains everything. I guess like a translation application of that might be if you were wanting to have a report written with stats involved, you can have that in there. And the nice thing about using things like the inline code is that you can start writing the bulk of the written material with the inline coding, and if the data changes, you just reknit, and it will reproduce the new figures and new inline stats for you. Something we use very heavily, and I don't know if it's drifted yet into other industries, is RedCap. So RedCap's a data capture software that essentially allows us to upload all the data. So that's how we centralize all of our data collection, is by running it off a website. And RedCap has a lot of strict criteria in how the servers that store the data are ran. They all have to be encrypted because they generally store personal or sensitive data. And therefore, one of the protections behind it is that you then can't download that data onto your local device, because no one knows how secure your local device is. So we tend to analyze all the data by pulling it directly from RedCap using an API. And I can't remember the exact package it is off the top of my head now. I think it might genuinely just be called RedCap R. And the API technology is very similar to what's used for making bank transfers or debit and credit card payments online, and forms a tunnel from you as the user to where the data is coming from. And by forming this single tunnel, there's no way that anyone else or any other device can nip in and try and identify what's happening. It's just a back and forth system. And so it's great for us because it means that we can have data that's stored generally anywhere in the world, and we can always access it and always get it through that way. And we know that the data is effectively, when it's put onto your device through R or through RStudio, it's sort of sitting in the memory, in the RAM. So if anything happened to your device, the data would just be wiped once the power's gone. So what we then do generally is we use the API in combination with RStudio Cloud, and I appreciate not plugging RStudio. They're not paying me to be here, but we use that just because it happens to be the software that the university is funded for, and it allows several of us on the steering committee to come together, and we can perform analyses on the data sets simultaneously through the API, so we can work on different documents, but we can then upload it all and store it all together. And it essentially means that the data never leaves the secure data store. So what have we achieved through this? So one of the things we've ran is hack days. So we sometimes go to conferences and run sort of breakout sessions, one of which was a full hack day. It was 9 till 5, and we had about 450 people all come together. They brought their laptops, they had R on it, and using the APIs, they sort of ran and did their analyses, and that ultimately resulted in the publication of a paper. So we managed to get a whole paper out of their efforts for the day, which was fantastic. And that just wouldn't be possible without R and some of the ways that it's been designed. I know this was touched upon earlier as well, but somewhat more recently, it was so it's got the Guinness World Record for the largest number of authors or co-authors, but it was also one of the largest studies ever performed, and it's the largest study that came out of COVID. So we're essentially looking at what some of the impacts were for patients that had COVID and emergency surgery. And we ran it internationally. So we had around 100, there was 116 countries involved. And again, that's just something that wouldn't have been feasible Without R and some of the sort of collaborative capabilities, the study was ran out of Birmingham, but it also utilised the data science team up here in Edinburgh, who are also the ones that store all the data. If you sort of look back 20, 30 years ago, there's no way that you could have had data that's stored up in Edinburgh be analysed in Birmingham or in France or so on and so forth without there being a risk of data leakage in any way. One of the sort of the more trying to think how to describe it. One of the other uses we use R for, and I'm sure it's perhaps one of the less common ones, developing Shiny apps. So I know R is not designed to make applications first and foremost, but we've managed to use it as a workaround. And again, the reason we use it is because us as a group, once we've learned to code in R, we just find it easier to stick with that. So we use it to produce the authorship list, and by using R, everything can be automated. So imagine if you were wanting to credit the 15,025 individuals and had to do it all manually, or were trying to do it in Excel and use mail merge or something, it just wouldn't work quite as seamlessly. So we use Shiny apps that allow individuals to essentially go on the website, input their personal data, and it then allows us to generate a certificate that's also been produced in R. And they can then generate that. It'll come out as a PDF, and that can be for their personal keeping. We also then have the authorship list, so we'll automatically produce this, and this will form a huge list of the authors that are involved, and it will then tell them how their name's displayed on the list, and we can then amend all of that as well on the fly. We've also more recently started to branch out. So this is one of the latest studies we ran last year, in which we use it for study management. So we're able to monitor how many patients have been uploaded, which hospitals are engaged. We can also then search down the leads and collaborators. I wasn't able to get a working copy into PowerPoint, but we end up using it to produce promotional materials. So we often have animated graphs and plots to sort of keep people motivated. So that's something that's very useful for us to do. We also sometimes produce progress reports. So this is what I've tended to do more recently in R Markdown, is have the progress report. It pulls the data off the API, and I've then written code, can't think which language it was written in now, that essentially runs this, boots up R, runs the code, produces the output, sends it across on an email out to everyone, and then shuts down R and closes it all down. And so that sort of allows a really automated process for progress reporting and keeping people updated, which might be a more useful application, or could be a useful application in other industries as well, where you're wanting perhaps frequent updates. If you could pull data off of stock and you wanted a stock update at the end of the day or at the end of the week or something, again, you could use the same with that, sales updates, that sort of thing, essentially based on the API. So we've ended up using it for that and sent it out to collaborators and data collectors with various advice on how they can improve things. Keeping on sort of the theme of the Shiny apps, we've also developed e-learning. So this was more to train up medical students and junior doctors about clinical academia and statistics. And again, it's difficult. I can't show the actual animations and the interactions, but we've produced Shiny apps that allow the individuals using the e-learning to move various cursors around, and they can see how the plots change. And that's, again, something that, if we were trying to develop that in another coding language, would be extremely difficult, and for myself and others in the team, near on impossible. But it's made very easy with R. We're applying the same knowledge we've had for analyses, just in a slightly different format. One of the sort of, this one is a little bit of a plug now, but one of the great resources, and one that I used very early on, was called HealthyR. So HealthyR is based up in Edinburgh, but they also have lots of free resources, and that includes having sort of work through tutorials written in Markdown, a GitHub book that gives some advice on how to produce for certain plots. And it's all sort of based around the tidyverse packages. So I noticed in the last talk that sort of base R was being used to through GLM, whereas I've generally done most of my work through tidyverse, and have sort of utilized packages based off of that. So yeah, you've got your notebooks, the introductory videos, and they do occasionally run in-person courses. But if you're sort of wanting to even just brush up on some general R concepts, the books here are all fantastic. And it just allows us to sort of look at different data points. It also tells us or has teaching on how to manage missing data, which is something I've used before in the past. So you can analyze the data, explore the missingness, and then if needed, you can also then use R for multiple imputations, which is just an excellent resource to be able to do. And something that I don't think I found ever quite as easy until I had tried doing it in R. And I think off the top of my head, it's the mice package, which is an excellent package for being able to sort of look at missing data. And again, it sort of runs you through the code using the built-in data sets and go from there.